Okay, in this video and others that follow, I just want to practice with Venn diagrams to show you how you can use them as proof of an argument's validity. Okay, now what we have up here is part of a syllogism. A syllogism has three parts, right? It has the two premises. One is a major, one is a minor, and then it has its conclusion. The conclusion here is yet to be drawn, so we don't have a complete syllogism. By the way, this is the minimal form of a propositional argument. You have to have two premises, two propositions, and from those two premises you have to be able to draw conclusions. Now, if we're not dealing with probability, and as you can tell in formal logic we don't talk about probability, we can also call this deductive logic. Alright, so that's what we're doing here. We don't have it figured out yet. We're going to deduce a conclusion. But what we do here is let's go ahead and I'm going to add, at this point I'm going to add the conclusion. Okay, so we're all A is B, some A is C. I'm going to put some C is B. So these are the two premises, and this is the conclusion that is drawn from them. Now, if you cannot see that this is valid, it might help to draw it out using Venn diagrams. V-E-N-N, Venn diagrams. Okay, so you get three circles. They're particularly suited for syllogistic work because of the three terms. You see that every syllogism has three terms to it. It can't have just two, and it can't have four. You have three terms that are introduced to you and worked with in the premises. And one of those terms is called the middle term because it has to appear in both premises. Here it's the A. Okay, so how would you draw this? My advice to you is to always draw the universals first. So for these, now, if this is valid, when we draw these two premises, we should have already drawn, by default, the conclusion. The conclusion will just show up. So let's see if that happens. Now, I'm going to draw the affirmative one first, the universal one first, which in this case is the top premise. All A is B. Now, A, you see the A and the B. Now, to draw this one out, I don't even have to mess with the C one, so I'm just going to pretend the C's not there. Okay? And now, the way we do it is everything that is open in the A circle has to be also in the B circle. To show that the space is closed off, you put lines through it like this, okay? So this space is closed off. Okay, anything now that's left open in the A circle has to be in the B circle. Did I draw that? Yes, I did. Now, it says sum A is C. To draw sum, you just put an X in that space. So the only space here of the A circle that's left, that's also in C, is right in here. I'm just going to put an X right in here. So sum A is C, I've got one in there. I want you to see that there's no other place you can put it. Now, you say, well, I can put it right here. Well, this is really technically in this same space. So whether you have 1 or 100, since the word sum means at least one, you know, you don't need all these other ones. Just, that's fine. Okay. But I can't put it here, and I can't put it here, and I can't put it here, and I can't put it here. To draw this correctly, I've got to put at least one X somewhere in here. And I've done it. Now, so I'm finished drawing those two statements. Has the third one already been properly drawn? Or has the third one already been represented by default of representing the first two graphically? Yes, because there is an X. See, in order to make this work, I need an X that's in the C and also in the B. Do I have it? It's right there. See? Now, it could have been right here too, but because I drew it right here and in drawing it, I fulfilled the requirements of this proposition. This one is valid. Alright, so in this short video you saw how to close out a space and how to represent the idea of sum in a category with, or in a space in the Venn diagram with an X. Usually almost always the A and the B and the C, I'm gonna locate them that way. And we'll continue working through this. Here in this case, I gave you the syllogism first. We drew the top two to see if the conclusion by default gets drawn, and if it does, then it was valid. Pretty soon we'll be dealing also with just two premises and see if we can draw them out and come up with a third.